This one. You get 106. 106 to 111. Oh, okay. All right, so is everybody on page 106 in your textbook? You need to be on there. Open up your calculator because you're going to have that up. So go ahead and do that also.
Can you show me how to pin it for myself? Because I didn't do it. So I go here.
Open yours up, Bunny. Yeah, just open it up. And then once you open up, right down here, right click down here. And then right click. Pin to text off. There you go.
Okay, thank you.
Now you got it. Now open your textbook up now. Let's see if you have yours. Can I see if you have a calculator or not, Buddy?
I did that.
You did? Pull it up and tag it on for you so you can use it. We're going to be using that today. Jeff, are you good?
I'm not sure. It's 12:47. Do I start with school?
Sir? Yeah, we're going to start right now.
Ms. Vaughn, what if I take a picture in my phone of like the pages or whatever you need?
Yes.
So I can, oh, that ain't gonna make sense. I still won't be able to look at home.
Well, you can though. That's what I was telling her. If you wanted to, while you're here at school, you can actually go and snip those pages before you leave here. So they're pictures, so that when you go home, you can open it up.
You can just go to your photos.
You just go to your photos and it's there. So that could be an option.
Stretch myself out.
Right, especially if you know the textbook is, and like I said though, but if you just go on there and watch the video,
Oh, yeah.
it'll give you everything you need, and plus it shows you how to do the math and everything.
I can copy
What
yours?
is that?
Yep.
Okay, cool.
Wonder what?
You,
I don't think.
You see, you want this or how it tastes.
I
I just told you how it tastes.
I hear what I'm saying.
okay, so I'm gonna put my calculator up here today when we need it. I'm gonna turn it on so we can do this together since I don't have the app, all right? So I've got that. So first thing is it asked you what the third law of motion is. So what is the third law of motion?
Of course.
It's the force of the motion.
Yeah, so every force has an equal and opposite reaction, right?
All forces come in pairs.
So if you, in pairs, exactly. What was one of the pairs we did yesterday that most of the time happened?
Force normal and force gravity.
Yep, exactly.
I think
Force
it's-
normal and force gravity, those are interactive pairs, right? Action, reaction. What else did you remember? What does the dot represent?
The system.
The system where the object is going. Perfect. What does it mean if I put a line on both sides?
Equals. Right?
Equals out. Correct. All right, everybody good so far?
Just
Fantastic. So what it did today is it just gave us the interactive pair, and it gave us this formula. Force A on B equals a negative force on B on A.
let me see something.
Okay. So what it says is a force A on B equals a negative force on B on A. So he's just telling you that one's going up, one's going down, right? That's the formula that you're going to have to know today. Remember what we just had. You always indicate what force it is, what it's acting on, and what it's acting by. Okay? Everybody good so far? Let's go to our sample problem, because really that's all. Everything else is pretty much something that you could read. Is very, very simple. It's just talking about the opposite forces. So if you would, on your textbook, turn to page 108. Everybody at page 108?
Yes, ma'am.
Fantastic. So here it says that a softball has a mass of 0.18 kilograms. What is the gravitational force on the earth due to the ball? And what is the earth resulting acceleration? Earth mass is 6.0 times 10 to 24th kilogram. Then it says it sketches the problem, right? So we have the earth. We have the force of the earth on the ball going inside the sphere, right?
Mhm.
We have the force of the ball on the earth going inside the other direction. And if you look, it tells us our net force is in the positive y direction. Remember, when you're looking at those, remember, y is always this way. This is always x. Remember, dry and mix. So if it's asking for the y-axis, it's talking about the one that's going this way. When it's talking about the x-axis, it's always talking about that way. When you're talking about net force, how do we figure net force?
With that, all of them.
How do we figure net force?
You divide it, you add it.
Okay, so if I had said this is 4 and this is 7. Okay, so what do we have? And the 3. Goodness, Lynn. Right? That's my net force. Because I'm taking those two, subtracting them. What happens if this was 4, but this was 7? It would be on the x-axis, right? And it would be a positive 7 going that direction or negative 7, right? That's net force. So we always want to look at net force of these two objects, right? Everybody good so far? So let's see what else it says. It says the mass of the ball gives you the formula, right? Mass of the earth, gravity, and then we're looking for the force on the earth on the ball and then the acceleration of the earth. So the first thing it did was take the mass of the ball times gravity. Do you see where they got those two numbers from? So we're going to do this in our calculator. You ready? Okay. So let's do these.
Oh.
Turn mine on. See if I can get this thing working this way. Mm-hmm.
I got it.
I would say, I know my thing.
So
What you say, Jake? What 18 times what?
-9.8.
mm-hmm. Exactly. You know where this goes.
Right.
So on my calculator, first thing I'm going to do is I'm going to turn my calculator on. Okay? The next thing I'm going to do is I'm going to clear it. And I want to look and see what my mode is. What should our mode be? What's our mode? Here's my mode. So right now I have mine in scientific and degree. Is that where I need to have it?
No.
Nope. Let's change it to normal. And let's change it to radian. Okay? Now, so what we're going to do is this number. So what are we looking for?
Wait, how you got this?
We're looking, so what I want you to do is I want you to open your bracket. So you're going to push that button there.
Hold up, Miss.
Point. Sorry.
My thing froze.
Okay.
The calculator. Okay, bracket. Go ahead.
Bracket, then in your decimal, 1/8. And you're going to close your decimal. You're going to open again. You're going to go down here to negative 9.8 and close your bracket and hit enter. What do you get?
I got it,
-1.
-1.764.
Correct. But the answer in the book says it's -8.
I got it.
Why is it -8?
It's small.
Because
1.8. Because the 6 here tells the 7 to round up. Everybody good so far?
No.
Okay, the second math that they have is just asking us about the earth ball, right? So that's a -1.8. Why? Because opposite equals the same number, doesn't it? So then the last one it tells us to do is we have to do F net over the mass of the earth. Are you ready? So we'll do that. Alpha y equals, correct.
I think it's
So
small.
you're going to go to alpha y equal, that gives you your fraction. Everybody got their fraction?
No.
Okay.
Okay.
Okay, now I'm going to do 1.8. I'm going to use this button over here to go down. And now I've got to put this big number in, right? Ready? 6.0 0 times 10, use the caret key here, and that brings it up, put 24, and then you gotta move this over twice to get it outside of the equation and hit enter. What do you get?
I think I messed up. 3E. Yes.
Yep. So you've got 3e negative
Hold up.
negative 25.
Right, I'm confused.
So what does that mean? You ask, go up here to your mode,
Right.
go over to scientific,
I'm done.
and then second answer, enter. Does it give us anything more detail?
But that's like 1024.
Man, can you help me some?
Mm-hmm.
I'm getting confused.
So what this means is this is going in the negative direction, sir, 25 times. So you got 3, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
Good.
That is our answer. Now, Jeffrey, where's your problem? What's the matter? What are you in? You're good. Okay. Alpha, Y, enter,
Right, just came up with this.
1.8, L,
Sorry.
6.0 times 10
They said tomorrow is senior.
caret
less. One more.
is 24, right?
Yeah, next week, okay.
24
So tomorrow is
Also, the only
senior.
game I'm be going to my whole life.
over.
Where were you getting
Yeah.
the tickets from?
Take a look.
Hello.
You must not be using the caret key.
No.
Don't know.
Oh, I still made some back.
Don't
I
know.
put a plus. To the time.
There we go. Now we know. All right, so now we're going to do a sample problem. Are we ready? Okay, so let's look at number 28. There's no math involved, thank God. All right, you ready? It says you lift a relatively light bowling ball with your hand, accelerating it upward. What is the force on the ball? Okay? What's the force on the ball when you're pushing it upwards? Think of the ball. So if this is the ball, right? You have something going up and something going down, right?
It's 28, right?
Yep. So what do we have? Well, I know Jay's told me before, force gravity's down here,
Unfortunately.
and force applied this time is going up
Yeah, because you do it with your hand.
because I'm pushing it up. And this is the thing. Most of the time it is force normal. You're exactly right, especially if something is working on something laterally. It's going up. Now let me ask you a question. Is this vector smaller than this one?
Yes.
Because he's pushing it up. So this one is the greatest. So what's my force net? In that direction.
Right.
That's all it's asking for that question. So you would draw the circle. That represents your ball right in your hand. This is your force gravity, force acceleration, and your net force is going up. That's the answer. Ready for the next question?
Yes, ma'am.
All right.
So that right there.
That's it. That's the answer. Number 29. A brick falls from a construction scaffold. Identify any forces that are acting on the brick. Also identify any forces the bricks exerted on the object on which these forces are exerted. Air resistance is ignored. All right. So our system is just the brick, right?
Yeah.
What's the brick doing?
Follow.
Falling. So what do we got?
Unfortunately.
And that's it. We're done.
What number is that?
That is the next one.
What number?
29.
29.
So,
Question, Jay.
it's just asking.
And remember what it said is it said ignore air resistance, right? We had this problem yesterday when we were doing that handout. Remember that handout? And what we had to do with that was what? When it was just falling, no air resistance. But then when they had air resistance also involved in that, then that would be up here, right? You got it? Good? All right, questions on those two problems. That's all you had to do. You just had to write those two things down. That's it. So then the next thing is talking about tension. We talked about tension yesterday. What is tension brought by? A rope. And that's all it's doing here. It's just showing you that something's hanging, and when something's hanging, normal force isn't there, but the tension force is there, right? That's it. So let's turn to the page. Next one. The next one talks about a bucket. And it tells us that this 50-pound bucket is lifted by a rope. The rope will not break if its tension is 525 newtons or less. The bucket starts at rest, and after being lifted for 3 minutes, it moves 3.0 meters per second if acceleration is constant. Is the rope in danger of breaking? Wow. So we have the mass, right? We have velocity final, velocity initial, and the distance. And we're looking for the tension of the rope. Are you ready to put this equation into your calculator? I'm going to write it on the board for you.
Hold on, let me get mine back up.
I said no. I don't think it's an engine.
Okay? Okay? This is what we're going to put in our calculator. Can you do that? All right, so let's see if I can turn mine on. And so I'm going to start with 50 first. So I'm going to open bracket, 50. That's what it's saying. 0.0. And I'm going to close my bracket.
There's another 3.0 on the bottom of the equation.
And then, yep. So then I need to open my bracket again, but now I need to do alpha, y, enter.
I got stuff in this for it.
And that is 3.0, but it's squared, isn't it?
Holy crap.
Then you go down. Then you do 2 times 3.0. Close your bracket.
Writing song.
I'm going to go over here and close this one.
That's the problem.
And then I'm going to add, open bracket, 5, 0, close bracket, open bracket, 9.8, close bracket.
Yeah, don't press anything.
I'm not. And remember, I'm videotaping this, so if you need to take your calculator home and practice, you can.
You gonna post
You
it?
got 5
I'm
points.
posting it, yes, ma'am.
You just got 50 points.
Yeah, 50 point. It doesn't matter if I put the 0 or not. It doesn't matter. It won't change the answer.
What she give me song?
65.
Hold on, don't hit it yet. Please, man.
What you get?
I'm gonna see what I'm about to get, bro. I got 565.
The rope will not break if the tension is 525.
Okay, go ahead.
It will break.
What?
Mine's in scientific notation. Let me change mine out of scientific, out of that side, because I was
I
showing you
get
the other one. Okay?
I ain't get that.
So it will break. So it's saying no.
Yes, it will break. So let me say to you, can you go back and watch this video and see what I'm pushing on my button tonight to see if it makes sense to you?
Yeah, but I just did it with you and I didn't get
And
You
it,
get 565?
what'd you get?
134.8.
Can I look really quick? And I Mike can see it.
I just typed it.
Okay, so first of all, you did that right. You did that right. You done 3.
Is it because I forgot the parentheses around the 50?
Yeah, it is. It is. Because look here, baby, are you listening to me?
Mm-hmm.
Whenever Miss Sloan's writing something, especially if it's on a test or something, your calculator should look just like mine. What it says here, if that has a 50, you know why? Because what happened is this 50, did you multiply that by 9.8?
Yeah. I put a 9.8 in parentheses, but I didn't put the 50.
It doesn't know to multiply those because there's no parentheses around it. There you go. We figured it out. Okay. Let's see. Let me give you another equation on the next one. So let's see what it says. Where are we? Okay, so let's go and turn and do question.
30,
Yeah, let's do that.
32 on it.
Let's do 32. Yeah, 32. Let's do 32. It says Diego and whatever is trying to fix a tire on Diego's car, but they are having trouble getting the tire loose. When they pull together in the same direction, Michaela has a force of 23 newtons and Diego has a force of 31 newtons. They are just barely getting the tire to move off the wheel. What is the magnitude of force? So what do we have? We have 23 newtons, right?
Yeah, go ahead, 31.
And then we have 31. Are they going in the opposite direction?
Yeah. No. Yeah.
They're going in the same direction.
Yes.
Since they're going in the same direction, what do you think we need to do?
And
Add them together. So you got to think 23 newtons this way,
54.
31 newtons this way, and it is 54. That was easy, wasn't it? That is the end of this chapter, believe it or not. Now, the only other thing I want to do is the handout I gave you yesterday, take it out. The one that we did with the force diagram, there was a second page. We're going to go, we're going to go over that second page today.
One handout.
The one I gave out yesterday.
the one you gave out right before the wheel.
Yes,
The
before the
diagram?
wheels.
Yeah.
The diagram.
They tell you what to put?
Yeah, that's it.
I don't know.
Maybe another thing I can eat is,
Don't eat it then, just in case.
Burger. Throw it away.
That's the one we did yesterday, so you'll have it.
I want a dripper. In here. I don't know. It's too much chocolate. You ain't got no, like the little.
Man, look.
Not peanuts, I don't like those.
Store, Jeffrey.
The circle coat thing.
Okay,
Cosmetic.
turn it on to the back page of the second page.
I got two.
number 14 or 15.
Jeff, I got you on that.
Turn this right here, guys. Turn to that page. Okay? I want you to try to do those. You see if you can.
I don't got that.
I know I'm getting it for you. Give me a minute.
You weren't here yesterday. You gave me that yesterday.
I gave her the one out that we did yesterday. I got to give her the second one. That's the one we did yesterday. Yes, the back.
We just took notes. We just made that one and.
We do just 42 minus 12 because it's too
Oh,
low.
this is getting.
See what you get. Here you go, baby.
And then she'll
Will we turn it in?
give you the wheels.
Yep.
Cause I don't know.
Okay. I'm gonna take the calculator off because we're not gonna need it. That's simple math.
They're at 3.2 14.
So let's look at the back first. So we're gonna do the net forces first. All right, you ready? Jeffrey, do you have yours? Do you have yours, ma'am? Fantastic. Go ahead and fold it in half. Fold it in half.
We're looking at
We're on this side, baby.
number 7.
We are on
14.
14 on the other side. There you go. Okay, so the first one says, what is the total box or the total force acting on the box? So we have a box. We have 42 newtons. We have 12, and we have 12. 12 and 12 is 24. 42 minus 24 is what? Well, that's 3. That's a 12. 12, 11, 10, 9, 8. That's an 8. That's 18. So my net force is going in which direction? This direction, 18.
So we read that.
So on your paper, write that direction, 18. You see how I got it? Okay?
Just put it in that picture then.
Yep, just in that
And
picture
that
thing.
first box, right?
That force to the right, 18. Okay, so let's look at the next one. The next one I'm talking about is the one that is the baseball. Okay. So on our baseball, what are the forces that we have here?
0.2 newtons going up and 3 newtons going down.
Okay, so what is my net force?
3.2.
2 point what?
3.
8. 3 minus 0.2, right, is 2.8 going down.
So
This is your net force. Okay, that's what we're doing today, is net force. Catching on a little bit better?
So we just added some subtracting.
And so now we have a dog, right?
But now,
We have 3 newtons going up,
15 going right.
3 newtons going to down. We got 5 newtons going that direction and 15 newtons going in that direction. Well, let's think about this.
3 and 3 cancels out.
This cancels out. Subtract those 2,
It's 10.
and so it's going to be in that direction,
10.
10 newtons. Got it?
Which one is that?
That one's the dog, which is the one on the bottom. Okay? Let's see about the bicycle guy.
Got 7 going up, 7 going down, 16 going left, and 25 going right. The 2 and 7's canceled out.
Those cancel out. What we got left? What's 25 minus 16?
9.
Okay? So we got 9 going in that direction. You got this? It's pretty simple, isn't it?
Mm-hmm.
This is net force.
Yeah.
Let's look at the scarecrow.
You got
So what we got, Jeffrey?
1.5 going up,
That's it.
and that's it.
Okay, so here we are thinking here. Is that scarecrow sliding down or floating in the air? No. So it doesn't even show us any of the bottom force, but we know there's a bottom force, isn't it?
Mm-hmm.
So I'm going to say gravity's here because he's not sliding up and he's not going down. So my net force for that one is going to be 0.
So we write net 0.
Net 0.
I was about to ask you, would it be 1.5% because it's going up farther?
Yeah, and it just says here that he's already attached to there. He ain't going nowhere. It's just missing the 1.5 because you can see the forces there. It just doesn't have the number, does it? All right, last one, pinata. All right,
It's a rope.
so we do have a tension force on there.
You got 3
Okay.
going up,
So we got 3 up, okay?
3 going down,
That's all right.
3 down, okay?
10 to the left,
Yep.
and that's it.
So what do you think our net force is?
The 3's cancel out.
Yep, they cancel out. You're exactly right.
So it'll be 10.
10 going to the left, huh?
Yeah.
That's it. That's easy, isn't it?
Yes.
Okay, let's flip over to the other side. We're not going to do this side because I'm going to make y'all do that for homework.
Like this.
Nope, open it up. Let's go to the other side. I'm not going to make you do these for homework, but we're going to talk about them for a
Which
few
part?
minutes. We're going to go on to the left side, which is question number 1, I do believe. We have to draw our net forces in this one. Okay, you think you're ready for that?
No.
No. not
Yes,
really.
you are. You're ready for this. Okay, so if it's a box sitting on a table, what forces are acting upon it?
Net force.
Force gravity, correct. Force gravity on the box by the earth.
And
What
force gravity on the box by the no force Newton.
Force normal, yes ma'am.
No, you know what I mean.
On the box by the table, right?
That's what I was trying to get out my mouth.
It's okay, but that's it, isn't it? You got that one, see? You said you weren't ready for
What did the B mean?
The
box. it. And T is table. So acting on and by. Okay,
You got it now?
That's MB.
okay, let's look at number 2.
Open it up and flip it over. Oh, we on number 2. On number 1, that's number 1.
Number 2 says a friction prevents the book from sliding.
Force friction?
So we got a box,
Force friction or force applied?
force friction on the box by the table.
And wouldn't it be force applied?
Well, we gotta have force gravity though, don't we?
Yeah.
Okay, so force gravity though is gonna be down straight. Force gravity on the box by the earth. You said right about the force normal. There's a force normal on the box by the table. Anything else? No, because it's not moving, is it?
No, but I was,
And it's in the opposite direction, isn't it, baby?
because I was thinking about force applied because it was going like kind of that way.
You're right. Let's do that. That's a good idea.
No, I said.
No, I was saying, I don't know.
No,
if
no,
it's
no, you're
right.
good. No, you're right, baby. Force applied on the box by gravity. But since it's not moving, these two have to cancel out, right? Those two have to cancel out, and that's what ours looks like. Very good, girl. Proud of you.
It's not like that.
Let's look at the next one.
Okay, now.
Boy pushes a box across the floor.
Force applied.
Okay,
Yeah.
we're looking at the box, right? Okay, so we got force applied on the box by the boy, right?
Mm-hmm.
What else we got?
Force, friction, no.
Force gravity, yep, force gravity on the box by the earth. One more force.
Force normal.
Force normal, perfect. Force normal on the box by the floor. It is going in that direction. This and this cancels out.
Because it wouldn't be force friction because it's not going.
Correct, right. So since it's moving and it's not stopped, we won't put another one. Perfect. You ready to do one more? Let's do the pinata with the hanging from the ceiling. Okay? So what do we have here? And be careful.
Force gravity.
Tension.
Okay, we got force, oh, y'all are good. Force gravity and force tension. Perfect. That's it. This here is an honor sheet.
Who's?
An honor sheet. And look how far you went. You did good. All right, put that away.
So we finished the homework.
Only thing you gotta do is the back part. You don't have to do the front part.
Inside right here.
Yep, just that side right there. All right, let's get our wheel out. And our goal today is to finish this bad boy, right? If we can. If we can, it's okay.
Try to get you back to it.
We can, it's okay. So if you remember, and I'm gonna remind you again what's on this wheel. So on the first part, you're going to do the first, you're gonna write the word first law, second law, third law, and what did we say? Diagram, free body
The
diagram.
force diagram.
Force diagram, okay. Force diagram. Okay, what are we doing on our second one?
Examples.
We're writing a word problem. Right?
And then the third one is your picture.
Picture from the word problem. Very good.
And then the big one is your information.
Yep, is the laws themselves, right? Law facts. There we go. Let me stop this recording.